Okay. Hello, everyone. I hope you enjoy the conference so far. And it's really great that you are here for this talk about profiling PHP applications. And in the next hour, we're going to find out what you can do when your site is slow and you have performance problems. So this talk is all about speed. And with speed, I don't mean the drug or any movie or game. I mean the speed of your web application. So we'll talk about why speed actually matters, what page speed actually is, how to measure the speed of your application in the right way that it really tells you something, and to find out where the problems are, how to find out where the problems are, how to make it faster. And before we start with all of that, a few words about me. I work at ResearchGate. It's a social network for scientists based in Berlin, in Germany. It's actually quite successful, about 4 million users now, so slightly outdated since last week. That's what the profile looked like. You may have read about us in the news recently. We have a table tennis, plate, and snooker and everything. We host user groups. We have people visiting us, and we are hiring. If there are any questions throughout the talk, just raise your hand. So this was a commercial thing. That's what is it. If there are any questions throughout the talk, just raise your hand. We have plenty of time for questions also in the end. The slides will be available on Joined In and Speaker Deck after the talk. And of course, this talk is also recorded, so you can watch it later on as well if you want to. So, speed. Why should you care about speed? Because it's important. But seriously, there was, in the last years, a lot of companies did a lot of research about how important speed is for web application and how it influences user behavior. And all these studies that have been done by various companies and various organizations, everyone came to the same conclusion that every millisecond, really literally every millisecond in your web application by delivering the application, the site to your users counts. These are some examples. For example, here at some e-commerce sites, they added a second delay on every page job, just artificially adding a sleep somewhere. And this led actually in this target group to a 7% of loss in conversions, 11% fewer page views, and 16% decrease in customer satisfaction, which is a lot and amounts to a huge amount of money. And more real-world examples is that, for example, Yahoo managed to increase their page by 400 milliseconds, and their traffic increased because of that by 9%, and they also had this tested against a target group where they didn't do the modifications. Or Mozilla, which had a lot of more downloads just because the page got much, much more faster because they added some caching to it. And there are tons of other examples. You can find them on the internet. And for example, here on strangeloopnetworks.com, there are lots of nice graphs about it for managers to convince them, hey, speed is important, we should invest in it. Once you have done this, the next question about this, okay, speed is important, but what actually is page speed? Of course, you have a server somewhere. All of us were probably maintaining PHP applications, so the server is an important part in page speed because a request from the user from the browser comes in. Then there is your big PHP application, which does its magic. In the end, returns some JSON, HTML, images, whatever, and returns this back over the HTTP connection to the user. So what happens here can influence the page speed greatly. If you're waiting for database queries for 5 seconds, your site is probably going to be very slow by that. But in most applications, that's only the only component that influences page speed, because usually you have a load balancer in a kind of bigger application in front of it that can influence page speed. For example, if the load balancer doesn't have enough slots to handle all the requests, it can influence that. And also in your PHP application here, it's usually not just one file, one script that does like 5 commands and then returns something. It's most of the time much more complicated. You have lots of controllers and subcontrollers and services and different components, and you're waiting on different databases, caches, doing HTTP calls. You have some kind of coroutines maybe in there, and all that kind of complicated stuff that can influence the page speed. So in one request, you're usually running over, I don't know, thousands of lines of code that can impact negatively somehow. So it would be really great to know what kind of stuff is going on here and how it affects page speed. And even more complicated, most applications not only consist of like a load balancer and a few PHP web servers, but they also talk to databases, caches, HTTP services, and also if you have a performance bottleneck in the database and your PHP script is just idling over it, it is important. Or if you have an external HTTP service you are talking to that gets you data, some external or internal APIs that also can impact page speed very negatively. So there's lots of stuff on the server side level that can influence it, that you need to measure, that you need to be aware of. And to make it more complicated, there is even more. There is this big cloudy internet thing. So once you delivered your page, you computed everything, you say, okay, here, good to go, please view it now. All the HTML content needs to be delivered to the user through the internet. Then lots of stuff can happen there. There can be slow connections, slow proxy servers in between, all kinds of stuff. Especially if you're in very remote locations somewhere, there can be mobile networks or bad Wi-Fi's, like sometimes, like yesterday afternoon, where the Wi-Fi broke down here, that can influence page speed. And if you cross this bridge of the internet, the cloud, then you have the browser of the user that also influences page speed negatively. There are some that are faster, some that are not. And once the code is in the browser, and the HTML is there, and the browser starts parsing it, it needs to parse it, of course, but then there's a lot of other stuff that needs to be fetched. CSS, images, JavaScript. The JavaScript also needs to be executed. So if you have strange loops in JavaScript and do lots of complicated stuff, that can slow down page speed enormously. So to sum it up, if you look at actually what the user sees when he accesses your page, it may be a few hundred milliseconds in the back end, but then a few more seconds in the front end that he waits for your application to actually be finished to be loaded and usable. So when talking about page speed, it's really, really important what happens on the server, of course, because 5 seconds on the server is really bad. But the rest of the whole stack is very important as well. So if we go to step 1 of finding out and trying to make our site faster, we have to measure all this stuff. Who is measuring page speed like this with front-end and back-end combined already? Okay, hopefully those of you who didn't raise your hand, after this talk, you're going to go into a company and back and say, hey, we have to do this. Because it is not very hard, you just have to do it, you have to spend a bit of time with it. And the most important part, and probably the most not so nice part about it, is it's going to hurt when you start it. Because you think, okay, my page is actually not that slow. Then you start measuring it. You have all these fancy graphs there, and then you see actually how slow it is for normal users. Because on your machine, it usually works fine. Like you have a new 2-month-old MacBook Pro with lots of RAM and lots of CPU power and SSDs, and you have a fast internet connections with like 50 or 100 megabits. Probably also the ping and latency to your data center where the servers are is not that large, because oftentimes the server are somewhere geographically in the same location or in a nearby location and not across the world somewhere. So on your machine it may be fine, the speed. But for users, the reality is lots of them have very old computers. Maybe not as old as this one here, but a bit more new. But like 5-6 years old with crap notebooks with lots of crapware on it that are very underpowered, and you notice this very quickly that this is influencing page speed very, very negatively. Or even worse, mobile phones. Of course, this is also an acceleration, but old smartphones with Android 2 on it are not very, very fast. And also the whole network stack is not very fast. Then you have broadband connections over mobile. And these have high package drops, high latency, and are also not very fast. Not everyone has LTE available on their phone. Then old browsers. IE6 is still around for 4. Okay, these are figures from October, but I checked last week. They are still at 4.9 or 4.8% worldwide. Especially if you have an international user base with users in China. I know you can't probably read it from the back, but China has an Internet Explorer 6 usage of 22%. You need to be aware of that. And if China is an important market for you, you need to be aware of that. The reason for it is, I guess, that lots of users are using pirated Windows XPs and can't upgrade in China. Thank you, Microsoft. Then there is also the internet does not only consist of users in Europe and United States. There are lots of people in emerging markets in Africa, in China, in India, in Brazil, and everywhere, or even Australia, where the distance between the user and your servers in some data center somewhere in Europe or somewhere in the United States is actually quite large. So they have just because of technicality, a much larger ping. So there's stuff you can do about that, multiple data centers using CDNs or something, if that's important for you. So, as I said, it's very important to measure the speed at the user side, to get a really feel of what the user is experiencing. How to do this? In modern browsers, there is a navigation timing API. Has everybody heard of this, the navigation timing API? Okay, it's very, very convenient. Supported, I think, in all modern browsers except Safari, I guess, still. But Safari is probably not that important as a browser if you're not targeting iOS. But what this API provides you, just in JavaScript, lots of measuring points and timestamps from everything that happens in a request. So from start of the user clicks on a link, all the redirects that happens, application cache, DNS lookup, TCP connection creation, then sending the request somewhere, SSL handshake, receiving the response, processing and fetching all the content, all the CSS, all the images, parsing the DOM, loading all the JavaScript until the page is really, really finished with loading. So if the browser of users support that, you can just get the data from there, you have everything you need, and then send it back to your backend somewhere and plot it in a nice graph. For other browsers, you have to do it yourself somewhere. Of course, there are libraries out there are also services out there. I think Google Analytics, for some example, does stuff like that. You can get with, I think with Piwik also some kind of these measurements. There are also open source projects like Boomerang from LogNormal who does it. And these allow you to get all these measurements as well. Doing it by hand is kind of tricky because of time offsets. You have to get the timestamp from a backend to the user, and then you have to calculate also with JavaScript a few timestamps. So I wouldn't recommend doing it yourself if you don't need to. And then you get nice graphs out of there. It's not important what it does, but you see then where the user, how fast the user actually is. And important here is the green line is actually, this is an actual graph we had on our application at some point for one page, where it was kind of slow. But you had here the green line, which is barely noticeable under the red line, is the actual time the backend took. The red line is the time where the first content, the first byte arrived at the user, and the blue line is when actually the page was completely completed and rendered. So there is a huge gap in here, and trying to make this gap go slower and making it faster is a good way to visualize it like this. How to get the data back to the server? The easiest part is just sending a tracking request somewhere. So you're doing an AJAX request after you have all the measurements you need, or just including an image somewhere with a dimension of 0, 0, and put all the measurements you have into this request. For example, the backend time was 123 milliseconds, complete time was 890 milliseconds, DOM ready event was fired after 580 milliseconds, and we were on the profile page. So we have this request. You should do it. You should probably not do very much there when answering to this request, because usually a very, very convenient way to do this is just have a server somewhere, some Apache, some Nginx server that does nothing but return a 0-byte response with the appropriate headers, of course. Then you can just do an AJAX request to that, or just include an image tag to this server, and then the server does nothing else but make an empty response and log this request in its access log. Once the request is in the access log with all this data here, you can have a small daemon, like Logstash, for example, tailing over this access log and putting this somewhere in a database to make nice graphs. Yes. Hang on, we need the microphone for the question so that others on the recording hear it as well. Yes.
How much is the performance slowed down by the tracking request?
Usually nothing, because after the page is loaded, you're doing a very fast request somewhere, so the user can already interact with the page. You're doing a request then, and you can just do it on another server. For example, you have a domain tracking.yourdomain.com, which has a totally different server, a totally different Apache or Nginx instance that just answers with 0 bytes, and your production system is not influenced by this at all. Even if the tracking server is not there anymore, you have no data, but that's it. And usually, because you don't do anything on it, in most web pages, one server is actually enough, and you don't need a huge setup for that. So does anybody has heard of Logstash before? Okay. Logstash is a very, very cool tool to do lots of stuff with log files, getting metrics, and it's very, very convenient for lots of cases. In our case, so Logstash has a very simple setup. It has a plugin system, and every message that gets into Logstash is coming from an input. Then you can filter it in Logstash with plugins, and you can send this message to an output. Very simple. You have plugins for nearly everything, so you don't have to write much of your stuff yourself. You just install it, configure it. It has a very low or pretty low memory footprint and CPU footprint if it's running on a server, so it's fine to run it on a production server as a small daemon. And in our case, our setup would look like this. We have our browser with JavaScript sending all these tracking requests somewhere to our tracking server. The tracking server puts this tracking request in our access log, does nothing more, and then we have a Logstash instance running on it, tailing on this access log. And so this would be the input part of Logstash. And then we need to send the data somewhere to graph it. One tool, of course there are many solutions out there, one tool that is open source and has a lot of users and usages is Graphite, which gives you a very, very good and performant database to store all these metrics, so you can actually store a whole lot, and it gives you also a rich interface to make nice graphs out of it and perform various mathematical functions on it, correlate different graphs with each other so that you get exactly the data you need in your graphs. So our setup there would look like that Logstash tails on this access log, parses all the data out of there, and then sends it to Graphite. In code, this is just example configuration, and this is literally what you have to write for this, and it's running a bit like this in our production system. You have an input tailing on the access log, here on Nginx access log. We have some filters. These are grok filters, which is basically regular expression parsing, where we parse, for example, the connect time out of here and the page name. We have an additional filter here to validate the page name so that others can not create metrics. Like if somebody sees a tracking request and manipulates it and sends it to a scroll somewhere, we don't want to create new metrics for pages that we really don't have. So if somebody would say, okay, I have a page not available or something, we don't want to create a metric for that. So we are dropping these messages here. And then you just send it to Graphite with the statsd plugin and have all the timers, for example, for the connect time in here. And then in Graphite you have your graph. You can revisit this on the slides later on in the configuration, but it's really, really just these few lines of code. So what we have now is the page speed of the pages we want to measure. Not only the backend time, but also the time the JavaScript took, the CSS took to parse and load, and all we need to actually tell if one page was fast or not. But can we measure more? And usually you can. For example, what would be convenient if you use load balancers, like HAProxy or something, they also have logs and lots of information in these logs. For example, they have information, most load balancers have queues, and if the amount of slots for one backend for your PHP application is full, a request gets queued for a certain amount of time until your backend is available or some backend is available anymore to serve this request. So this information is also available in the log, how long a request was queued until it was handled and so on. So it's also very, very convenient and nice to have this data in graphs as well. And there you can do the same thing. You have one log file, you install a Logstash instance on this machine. The Logstash instance tails on the HAProxy log, for example, passes the XHProxy log, maybe mutates it a bit so that the keys are fine, because dot in the server name is not allowed in Graphite as a key name. And then you can send it to Graphite as well the same way. And you can do this with all kinds of logs or information that you already have in your system. If you have some databases that have slow query logs, you can do the same. Or if you have some HTTP service in the backend, you can do the same as well. Also, you can log information this way directly from your PHP application. For example, if you want to count the amount of cache hits and misses that you have in your application, you can just send, also from within your PHP applications, you can send a tracking request server to server to Graphite, and Graphite then will plot this as well every time you have a cache hit or a cache miss. Or you can measure how long an SQL query takes in general, and so on. What's also important is with Graphite and StatsD, you are sending UDP requests from your application, from the PHP application. So it's actually non-blocking, it's really fast, you don't have to wait for a response, so you can go really crazy with that, and there is not a huge performance overhead to do it, like to do a few hundred tracking requests on every user request that comes in. So you have all that. That you know now how many cache hits you have, how many cache misses, how long an SQL query takes on average, how long HTTP requests to some APIs takes on average. Now what you can do is make it more fine-grained. I already said a bit, you can measure it by pages. For example, how long took all this stuff on my homepage, on my profile page, on my publication page, on logged out pages. You can also plot and graph it and measure it by browser additionally. So you know in Internet Explorer it usually takes this long. That doesn't make much sense with backend stuff because your backend is very browser agnostic, but with the frontend stuff it makes very much sense to measure it by browser. Chrome was faster than IE, for example. You can measure it by country, which is also kind of nice, or by maybe not, if country is too verbose, by continent, so that you see how much slower you are in Asia than you are in North America probably. You can measure all that stuff for logged in or logged out users. So maybe the logged out performance is not that important for us, but the performance for logged in users who already registered is really important, and probably is also very different because there's much more dynamic data involved there. So we may want to measure this differently. Also, for example, how long SQL queries took for logged in or logged out users, or measure it separately for heavy users, because they probably have lots of data in your application. They probably have much slower response times because of that. For example, they have 5,000 followers, and it's probably way harder to compute a follower graph for them. But these users are also the most active ones, so we want to keep them really, really happy. So it makes sense to do that as well. And when you have all this data there, you probably should build some dashboards to visualize all that, and then define some goals where you want to go. First, you go crying, because everything looks really, really bad, and then you can define target goals. Hey, that's what we want to reach, and then you can iterate over it and try to get faster and faster. And when you see with every release that these curves go down and actually response time was better and better, it's also really motivating. And with that, we come to questions so far about that. Okay, then we come to step 2. Now we have all this data. How do we find out where the problems are? And the normal way to do this is profiling. There are lots of profiling tools out there. One of them is called, and probably the oldest, is called Xdebug. Xdebug has lots of features, like setting breakpoints somewhere that are very convenient, and then stepping through the lines of code to analyze why something is not happening like you thought it would be. It provides nice error displays that are much nicer than just the usually PHP error displays or stack traces or vardams, and it allows also to profile a web application. Setting it up is very easy. It's just a pickle install Xdebug, and then you can enable the profiler in your PHP INI settings. For example, you can enable it by a trigger, and then each time you have this Xdebug profile field. Yeah, no problem. Each time you have this Xdebug profile query parameter, for example, then a profile is written to disk, and you can analyze it with tools then. One tool, there are also lots of tools for it, for example, Webgrind or Qcache grind or Kcache grind, that allow you to then see the whole call stack, how many invocations you had per function, how long it took, and so on. And let's see, I prepared a small demonstration for that. So this is, for example, a Qcache grind output of one request of Symfony 2, and I'll just make this a bit bigger here. So normally you should be able to make it bigger if you're not an imbecile like I am. Okay, but in this small window here, you see the whole call stack. So it went through the HTTP kernel, then added some logging records. You can click on it. On the right side here, you see all the callers. So who called these functions? You see what functions is called, and you can step through it. You see counters there, and also somewhere how long it took and how long the code of this function was. So this is very convenient to, in a very detailed level, see what your code did. I love slower. Now it's fine on my machine, on my window here, with a big resolution. Okay. One thing with Xdebug is it's only a rough indicator about the performance of your application, because Xdebug actually slows down PHP, and it slows it down a lot. So if something is measured with Xdebug to take 50 milliseconds, it's probably way faster on your production machine. And also, if something with Xdebug enabled takes 50 milliseconds and another thing takes 100 milliseconds, it does not mean on the production machine without Xdebug enabled that it is actually double or takes double the amount of time. So it's just a rough indicator for that. Also, because it slows, as long as it's installed, it really also slows down the application a lot. You never should enable it on a production machine, but only on your local dev machine. But on the other hand, oftentimes on your dev machine, you have only not a lot of data. It's actually kind of hard to profile something with production data. And with production data, also the speed is probably, or the behavior of your application is probably way different than on dev machines because of all these kind of things that only happen on production. So one tool that you can use in production to profile stuff is called XHProf. It's developed by Facebook, so they care about performance. You can just install it. If it's not activated, it doesn't have any performance overhead, which is very nice. And then you can just activate it on production if you need it, or even better, just activate it automatically for a very, very small subset of requests, maybe only 0.5 or 1% of a request. You can just, with a modulo or something calculation, you can just activate it then and then automatically write the profiles, and then from time to time you can log into it and see how the profiles went and how the requests went and how fast or slow something was done. Also a good thing is not only activating it on every 5,000th request, but also enabling or building a few lines of code to enable it by cookie. So if you need something really and you want to do it in production yourself, you could just set a cookie and then also write a profile somewhere. There are several tools for XHProf to visualize that, and the nicest one and newest one is called XHGUI. These are a few screenshots there. It's basically very similar to what you saw with didn't really saw with Qcachegrind. The interface is way nicer. It's a web application, which is pretty good because XHProf just stores all the profiles in some database in production, and then you can have somewhere secure XHGUI installed and look at the stored profiles in your database. This is a profile also of a Symfony application, and let's see if I can show it also live, because this is much nicer than screenshots. Okay, smaller browser, and okay. So these are all the runs of XHProf profiles I had here on this machine. I can click on one of these requests, so I have an overview of all the requests. I know how many microseconds they took, how many memory they used over here in bytes, which is also a good indicator. If the memory usage is very high of one request, probably something is leaking there and something is going wrong, and this also has a bad performance improvement. You can click on it here. You can also search for URLs, but here is a profile of the page of one profile. You have nice graphs that tell you, for example, what codes and what functions were the most slow ones or the most expensive ones in memory. You have then also, if you scroll down, the same as with an Xdebug profile, a list of all functions that were called, and you can sort them here by basically everything: CPU usage, memory, cost, and wall time, and everything. So this is really convenient to really, in a fine-grained way, try to find out what happened. Of course, you can also click on every function. So for example, this static extension get name thing here. Then you see what these functions and how often it was called, for example, and what functions these function called, and you can really go down through your source code. This is really, really convenient. Okay. Another tool that can help you with pinpointing performance problems is called php-meminfo. It's actually very new. It came out like 2 weeks ago or so. Somebody put it on GitHub. And what php-meminfo does, it's very simple. You can at one point in time call the function, and it logs the amount, all the objects you have currently in PHP instantiated, and the reference count on these objects into a file. And this can be really interesting. So a file may look like this. Oops. Okay. So this is a prepared file of also my small Symfony application. I have a big list here of all objects that are instantiated at the point where I call this logging function, the amount of references I have to it. So for example, most of them here have one reference, and if I go through it, I may see, for example, that I'm instantiating more objects of something than I would need to. For example, I have here very many stopwatch objects. They are probably good for debugging, but if I have them in production, they are probably kind of slowing stuff down. So that can also give you an indicator about what really happened before in your request. Especially if your application gets more complicated and you have lots of classes and objects, sometimes it's very easy to not have a track about that anymore. And also this extension is very new. It's on a heavy development, so you can expect probably a few more cool features coming into this extension as well. Then, next, something very useful is stuff like the Symfony or Zend framework or whatever framework you use, debug toolbars. Most frameworks come with these kind of debug toolbars. Who's using Symfony 2? Who's using Zend framework 2? Okay, you have probably already seen stuff like that, and I'm very sorry, but it's hard to see because the toolbar is always in the bottom, which is kind of hard with the screen size. But let's try to bring it up a bit more. With Symfony, you usually have like this small of a toolbar that gives you information about how long this request in the backend took, like 680 milliseconds for some reason. Okay, it's a vagrant boxy, how many memory it took. A bit information about the routing, what controller it was on here. Session information, the amount of database queries I did, how long every database query took, and I can also click on it and see more detailed information on a big screen. And this also gets saved into a database or into a file. It depends a bit how you configure it, and it's very useful information to debug it. You can also run this then on production for a small amount of requests. Of course, these users should not see the toolbar, and you can just enable it for all developers that they see this toolbar in production, so that every time you see red marks somewhere because some database queries were slow, or you see this page actually took 5 seconds in the backend, to make it really, really visible what happens there. If you don't use Zend Framework 2 or Symfony 2 or another framework who has some kind of these toolbars, you can still just take the Symfony 2 toolbar and use them in your own product or in your own project. So it's not very tied to Symfony. You can just take the code, put it somewhere into your framework, and use it the same way. That's actually what we did at ResearchGate, because we're not using Symfony 2, but we just took the code, adapted it at 2 points, and then basically it looks the same, works the same, and we saved lots of time by not implementing all this ourselves. And it's really, really useful, because what you also can do with at least the Symfony toolbar and also the Zend toolbar is you can extend it, which many people don't actually know, but it's very easy to extend it with your own stuff you need. For example, if you have, okay, I'll show you a bit of examples later. Again, these are a few screenshots. I'll show it to you live because it's more visible in the back. There are lots of extensions already on GitHub, which is very nice. For example, for measuring HTTP calls to external APIs that you are sending out, to have measurements there and have all the requests and responses there. But you can also extend it with your own stuff. This is, for example, a view of the toolbar at our platform. So I did this like half an hour ago or so. You see there are much more buttons in here. For example, here is a list of all the components we have on the site, because we have 500 different front-end components on the site. So we have a big list on it there. We can click on it, see the data that's actually in their component in a JSON object, which is very convenient. For debugging stuff, we see which release is currently online. Here it's the release 40.09 with which revision, and we have a few more information from the headers. And of course, we can also click on stuff. For example, have such a timeline view where we just set timers and time pointers in different parts of the backend. Same as the Symfony is doing, to see, for example, how long each component took to fetch the data and then render here. This is not really new. Here's an example of SQL queries, how long they took. So for some reason there are very many, but very fast SQL queries in here. What we added, for example, is a list of cache requests we did to see actually if we have cache hits or cache misses. Here we had a cache miss, which is probably not that good. Or we had actually a few cache misses here for some reason. With all the cache keys that were fetched, we have, for example, information, this is more interesting, information about all the front-end components, again in a nice fancy graph that we render with D3, and also what data they fetched and how long it took, so you can theoretically you can hover over it here. Right? Okay. It's hard to see in this small window, but you can hover over here, and for example, this 2 is the time it took to fetch the data for this activity stream here. And this makes it really, really visible what happens in the application, and also helps you to pinpoint performance problems and where in the code and which component they actually are. This is another example where we are just logging every metric that we are sending to Graphite from our PHP application. For example, we are sending all cache hits and misses there, and if you scroll down it, we actually do this quite a lot. Yeah. So there's no counter on it, but it's not also we're measuring the time here, how long it took, and it's in the microseconds. Also, what we are doing is, even all this in microseconds would take a bit of amount of time, but we move it to the end of the request. So the PHP script run is started when the request arrives, then the PHP script runs, and at one point in your PHP script you can say, okay, we finish the request now with Nginx, and then you move all that stuff that is not really needed for the user to see for the generation of the page, like all this tracking stuff, to the end of the request. So we just calculate all the timers, save them somewhere, and at the end of the request we iterate over all that and send that to setc, so the user is, even if that part would be a bit of slowdown, the user is never influenced by it. So I would really recommend for you to look into these toolbars and think about what you can do in your application. We also add stuff like experiments that are running. We do a lot of A/B testing, so we add to the toolbar which experiments are running currently, which variants were chosen. You can go really crazy there. And it's really worth it, because if you start doing this, you will find a lot of bugs very, very quickly, or a lot of performance problems very, very quickly that you never knew you had before. So you now all did that. Oh, questions to the toolbar thing? Yes. There's Mike coming.
Sorry, my question is not about the toolbar, but it's regarding the tools you introduced before. Do you see any advantage by using those tools, the monitoring tools, compared to like a tool like New Relic, for example?
What was the name?
New Relic.
Okay. The benefit is none. The only benefit is internal. So New Relic can become quite expensive, but it's a really cool product. If your company says, or your CTO says, yeah, great, we're using it, we're paying for it because it gives us a lot of benefit, and it's fine that another company has this data from us, great, do it. At some point, you're growing big enough that it's becoming so expensive that putting the amount of effort into it to do it with open source or do it yourself is worth it. Also, you can do a bit more stuff there because you have the raw data available. So you can just do your own calculations there. This is also a slight benefit. But New Relic is a really great tool. It's fine if you are allowed to use it to do it. Yeah, so Both is fine. The important thing is you have that you do it and you have the data somehow. Yes, here's another question.
The thing where you delay the timers being sent to statsd until after the request has been returned to the user, can you do that with Apache and more PHP?
You have to put the stuff into shutdown handlers,
right,
the code. Okay. Because you don't have a function call where you can say, okay, request is now finished, send it to the user, it's now completed, don't wait, shut the connection, everything. You can only do this with fast CGI. I think it's fast CGI _ finish request or something. Okay. With Apache, you have to do it in a shutdown handler.
Thank you.
But that's also fine. Now that you have all these measurements, what you can then do now, and you also pinpointed where in your code something is slow, the only thing missing is fixing it. That's something you have to do. I can't really help you with it, sorry. It's really part of your application, and there's so much stuff that can go wrong. One important thing is about fixing all that stuff is keep up to date on the latest stuff that's happening in the world of web page performance. There are great of many resources outside. Of course, you can first go to conferences, talk to people about what they are doing, and then there are a lot of blogs and publications out there telling you about page performance and performance tricks and what they are doing, what problems big companies had, how they solved it. And just one resource is perfplanet.com. They have articles from engineers from all the big companies, like from Google, from Twitter, and all they are really caring about web performance. So it's also a good thing. It's also a good thing to just read up on it. For example, who does domain sharding on the application? So domain sharding is when you load images, and you not only load images from one source, you have your CDN, but you have basically image1.yourdomain.com, image2.yourdomain.com, and so on, image3.yourdomain.com, to just have more connections available in the browser. Who's heard of that? Most. Actually, it came out, Etsy did a few experiments in there. Doing too much domain sharding is actually also bad because you have some TCP issues then, because you are basically hogging the TCP connections. And this is very bad in performance. So they measured this, they measured it, and what they came up with domain sharding, the good amount of numbers for domain sharding is just having 2. And before that, everybody thought, okay, the more the better, or have 4 or something. There's a question. What's a question about that? But this is they did this in a blog post last December, I think, and it was really interesting to read up on it. And they were really surprised by the results as well. So just an example, it's good to read up on these blogs. Yes?
Just on domain sharding.
Yeah.
We use Speedy to multiplex HTTPS requests.
Mm-hmm.
That's just kind of like an alternative.
Yes, if the browser supports Speedy, this is great, but not every browser does at the moment.
Luckily, it's for an internal app.
Yeah, yeah. Then it's of course awesome if it's internal. Yeah, there's a question in front of you.
Hi. One comment just came up at one meetup. I was in London, and it turned out that the browsers, they are now supporting opening, many connections. So the domain sharding is right now not so beneficial. As you say, so people realize that, and they actually change their code, to use less of those, really.
Yes, this is also something that changes over time. So it's good to measure it, and for example, if browsers update and more users have modern browsers that have open more connections and do it in a smarter way or support Speedy, to have these measurements all the time and see maybe, oh, we get slower for some reason, and then you can dive down into it and see why, because you haven't changed that much. So having all this data is then also very beneficial for these kinds of things. Yeah. But the most important thing to remember is really speed matters. And we are actually I'm finished with what I wanted to cover. We are very good on time. If there are more questions, I'm happy to take them. And if not, I have some backup slides also about performance hints and what you can do to improve performance. But questions first.
Yeah, hi. Thanks for a great talk. I've got a question about the navigation timing API. I haven't looked at it, obviously, because I've just heard about it. I'd like to measure the time it takes, the complete round trip it takes for a new visitor to my site to see, say, the homepage. Because when they first see my site, nothing's cached. And like, I think if we could have a metric in Graphite that records that, that would be great. But does the navigation timing API give you anything, any insight into the start of that request, which is before someone even hit your site?
You only get the measurements of this specific request, not in context of others. But what you can, for example, do is you can, if in the backend, you can see if the session is newly created. And the chance that if the session is newly created is very high, that not much is in the cache for this user, because also caches are finite most of the time. And also, if it's a logged-in user, you could see is it a returning user or a first-time user or something. So what it can do is just render out in some JavaScript property of variable that says, okay, it's a new session, or it's an already existing session request in a session, and maybe use that also as a key for metrics.
Okay, but do I have any insight into exactly when the user, say someone's on Google, for example, and they click the link on Google, is there any way of retrospectively finding out when they clicked that link?
Yes,
it's
great. From link clicked to through all the redirects you are doing until the page is fully loaded. So it's not when the request is sent, it's even before link clicked, then TCP, SSL handshake, TCP connection created, and all that stuff. You see in there.
Then that's really good. That's what I was hoping you'd say.
Yeah.
Thanks.
There was another question over there, I think.
Are there any, would you say, magic numbers for what is fast enough and what is not fast enough? Or is it really dependent on the application and the speed of the user's connection, etc.?
It depends who you ask. For consumer-facing stuff, I would say backend, all in all, you should aim for under 1 second. Okay. This is like, it depends also a bit on how complicated the page is and looks for the user. There's also a negative effect, which is really interesting, that research has found out if the page is too fast, also users are not trusting it anymore. Like if you have a complicated page and it took only 150 milliseconds, then the user says, oh, there is something wrong, something is broken. I'm not trusting that. So you have to be aware of that effect as well. So, but I think like a rule of thumb, something for consumer-facing stuff being under 1 second is really, really awesome. All in all, just not under 1 second until the user can interact with the page. Like when the DOM loaded event is done. You can do lots of stuff, then load stuff asynchronously afterwards, or load stuff that is under the fold of the browser afterwards as well. But it should take under 1 second for the user to actually be able to interact with the page, or to get any kind of feedback. Yeah. So, another question, yes?
Is there a standard logging format for the times that should be used?
Standard log format, I would just use, when measuring page speed, I would just take milliseconds. Measure milliseconds.
So I meant that, so that you can feed the data into different tools easily.
Yeah, so you should not measure timestamps, because then you have issues with how clock settings are and on different machines and time zones and everything that goes in there. Just measure on the same machine in the same environment how many milliseconds it took between the 2 points, and then send this and measure this. Yeah, if you want to, I can continue with my backup slides. 1 second. There's awesome stuff in there, I promise. So, some hints on better performance. These are in 3 parts, and for the first 1.5 parts, I can go through them very quickly because they are kind of obvious. Because you have the obvious things you should do in your application. Enabling GZIP, using CDNs, looking at your DB queries and doing the indices right, so that your DB queries are as fast as possible. You should minify your JavaScript, you should minify your CSS, you should concatenate your JavaScript and CSS so that you have not like 500 requests on every page, which is especially bad for mobile. You should look into your caching headers, if they are set correctly, especially for images and JavaScript and CSS and other static files. I'll just include these points also then into the slides I publish on the speaker deck later on. You should enable opcaching on PHP, like APCU or Opcache or something. You should look into caching your SQL queries, HTTP calls you're making to APIs somewhere in memcached or something, if it's data. You should look into APCU or userland APC caching to cache configuration files, for example, templates or whatever you want to read from the file system. You should look into memcached. There was a great talk about memcached from Eli yesterday. Look at the recording of him. You should upgrade PHP. Who's running PHP 5.5? Awesome. Who's running PHP 5.2? Upgrade. Who's running PHP 5.3? Upgrade. It's worth it. It's really worth it. You don't only get the new, you also get the cool features that the new PHP versions have, but the performance improvement is astoundingly great. And there is a link comparing that. You see, when companies upgrade, you see graphs that go like this in memory usage and response time. So it's really, 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 really worth it. So these are the obvious things. Do them. The not so well-known things, we already mentioned Speedy. Enable it. It's just installing mod Speedy on Nginx or Apache, and it gives you small performance improvements, especially if you are using SSL or TLS. So this is really, really worth it for Chrome and Firefox. Minimize the amount of redirects you have. So if somebody comes to your site and goes to example.com, you redirect him to 3wexample.com, then you redirect him to https 3wexample.com, then you redirect him to https 3wexample.com/home. This is actually a few redirects too much. Limit it. Each redirect costs time, especially on mobile. Check image compression for all your icons and logos and all the stuff you have. There is a great, can't see the URL, but it's on the slides. There's a great plugin for Grunt, for example, called ImageMin, or there are tools, command line tools that you just can run over all your images, over all your static files, and then just recompress them losslessly, and you save, I don't know, probably if you have never done this before, a few megabytes or in total on all your images. This is great and not much work. Compress your HTML output. You don't need all these extra spaces and new lines and everything in the HTML you serve to the user on production at least. So if you have some template files somewhere, maybe have a compilation step on deployment which removes all the excessive white spaces there. Check YSlow and Pagespeed and all these tools that are out there because they tell you a lot of what you are doing wrong. Enable DNS prefetching for your CDN hosts. This also saves like a few milliseconds here and there. DNS prefetching means in your HTML code, somewhere in the header, you say just, okay, I have a few hosts that I'm probably going to call later. While you're at it, while I'm sending you all the data, please already do a DNS lookup for these domains, for where you host your images and JavaScript and style sheets. So you're doing the DNS lookup a few milliseconds before you actually request it, and probably the DNS lookup was already done then. This is like also 2 lines of code, and you're saving it. Everything counts. Move as much complicated and expensive logic as possible to asynchronous workers. Use Gearman or stuff, or Q's RabbitMQ or something to, for example, when you send mails, you probably don't need to send the mail in the request that is service HTML to the user. You can just throw an event or create a job on Gearman, and then later on have a worker which actually computes and sends the email. And then the crazy stuff. Okay, Varnish is not really crazy, but if you have static content somewhere on the page, you can use it. With Varnish, what you can do is have a reverse proxy cache stuff before your application and use edge side includes. What does it mean? I have my application, for example, my profile page with the publications components, about me component, the left column and institution component. And for example, let's just say the about me component usually never changes. And if it changes, we can probably leave it there for like a few minutes or so in a not so nice version. So what I can do is, in order to not needing to compute this about me component, I can just render an edge side include tag with an URL instead of the about me component. And then what Varnish does, it sees this edge side include and does another request to your PHP backend to this URL you specified here. This URL should then return the about me component, and you can set different caching headers for both these two requests, like the request to your actual profile page and the request to the about me component. And then, for example, you can say, okay, about me component, cache me 1 hour or something. I'm valid for 1 hour, and then for the next request to this page, the profile component, because it doesn't have any caching header, will be fetched from the PHP applications. It still has this edge side include in here, but the about me component will be served from cache automatically, which is really, really awesome if you have static stuff in there. You can also do the other way around, for example. You can say, my big profile page is very, very static, so okay, profile is probably a bad idea. My news page is very, very static, so I serve it from cache, set the caching header there, but there is an edge side include for the comments section, which should be up to date always. So what happens then, for the next request, only the comments section will be served by your PHP script, and the rest will come from cache, which is really, really awesome. Then, if you don't want to install Varnish and all this stuff, and all the stuff needs to be somehow up to date all the time because everything is very dynamic, you can also use something very similar to just load components or stuff on your page asynchronously. For example, stuff that is below the fold or on the right column or not that important. Same thing, you have this about me component. This is probably somewhere on the far right down somewhere, and we don't really need it when the user should interact first with the page. So instead of computing all this stuff and rendering it, we can just render a small placeholder, and then at the end of our page, render a script tag that does an AJAX request to some URL, loads this component, and then replaces the placeholder with this component. If we are doing this, for example, extensively for these small recommendation components on the page that are very heavy to compute, take a few milliseconds, and are not that important because they're somewhere on the right. What you then can do is also flush content as early as possible. Most web frameworks like Symfony or Zend or something put you into the kind of direction that you get a request, you calculate everything, you render everything, you put it into a response object, and then you flush it out to the client. With HTTP, what you can do is actually, you can flush out stuff to the client all the time. So while you are still computing something on the bottom of your page or somewhere, you can already flush the header out to the client because it's already ready, it's already computed. The user sees the header, has some response, and then you compute the other stuff and flush it out to the client in the same HTTP call as well. As we said, move logic to shutdown handlers as much as possible. If you do tracking stuff, analytics stuff, or something that you don't need for actually computing the HTML, move it down to shutdown handlers. Very easy. Register a shutdown function, and then if you're using Nginx, you can also use fastcgi finish request to say, okay, request is finished, close the connection. If you're doing HTTP calls to APIs, you can use promises or futures. That means you say, okay, I want to do an HTTP call here to example.com, start the HTTP call, then I can do lots of what it does internally. This is a library from Facebook called libfutil, which is really, really nice for that. What it does internally, it opens a socket, sends the request, and then it does not block, but you can do other stuff. And then if you really need the data, so you get back a future object here, and if you really need the data, you say future resolve, and then only at that point in time, your code blocks and waits for the request. And in many cases, your request is already finished, and the data is already there, and then you could do other and more important stuff in between. This can speed up a lot of stuff very, 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 very heavily. Then, if you have users are use modern browsers, you can do stuff like pushState. So that means, I'll just show it to you in an example. If the internet connection is working, hopefully. Looks good. So you have, in this case, you have a few tabs here. And you can imagine if I click this tab, this part of the page stays the same. So why should I compute and load it again? What I can just do is, when I click on here, we fire off an AJAX request the lower part of the page, and with an AJAX request, and then just put it into this div container, and this part stays the same. And with the pushState API, we already also changed the URL here. So if I do, which is very nice, because then I can do a refresh, and are on the same page again. Also, what you did see here is this flushing content early. that it actually, or here you see it hopefully better. So we flush here the header, and then the other parts of the page appear. And this is one HTTP request, but we flush content one after each other. This does not make your page faster, but it appears faster at the user, so you're tricking a bit. And then, if you want to be really fancy, you can do stuff like BigPipe. Who has heard of BigPipe? Okay. BigPipe is a technique that was made public or is used by Facebook a lot and also a few other pages, which is basically a combination of this flushing content early, doing stuff asynchronously. If you have these pages, like here, you have 3 big components, like a header, left column, right column. What you can do is you identify these components, and then you can flush out the whole page, basically, the menu, the header, calculate all that, and for the left column, right column, you flush out placeholders. Then you flush out the rest of the footer and everything you need. Then you flush out all the JavaScript to bind already the header on there, so the user can interact with the header. And then you start computing in the same HTTP request the left column. You can render out some JavaScript that then takes the computed left column HTML and replaces the left column div with the computed thing here. So this can take a few more 100 milliseconds because there are HTTP calls happening there. Then the left column is there, and then you can do the same for the right column. And this way, it's basically the same as flushing content early, but it's at some places easier to implement in your framework because you're rendering placeholders and then you do stuff afterwards. And what you also can do, you can prioritize content easily. Even if your DOM if the order of your DOM is not like the prioritization we want to do, you can render content in another order that you want to. An example for Facebook is what they are doing. That's me hoping now that nobody put anything on my Facebook page that is not good for recording. Oh, a cute baby picture. Hi. That's awesome. So what they're doing is, when I do reloads here, you see that they have the menu first, then the feed, then the left lower menu, and then the advertisement on the right. So DOM-wise, it could not be done like this if you just flush out the content one after each other, but by using this BigPipe thing, they can just prioritize and say, hey, this content here is more important than this one or this one, even if this is in the DOM speaking on top of this content. And a nice thing about Facebook is they also have a possibility to they have a blog post about it, and they have a possibility to deactivate this BigPipe feature and render all this content in a single flush, like computing everything and then flushing it in one go to the client. And if you do this, you see that Facebook is actually really, really slow. So compared to using BigPipe. So they are cheating a lot on this as well. And it's nothing bad. The user has just better user experience. And with that, and all these crazy tricks, thank you very much for your attention. If there are questions, I'm a bit over time. We can do questions? Okay, we're out of time. I'll be outside after like 1 or 2 minutes or in front of here. Please go to join in, rate all the talks you have seen, rate this talks, give comments on it, because it's like the second time I did it, the first time with all this extra stuff, the first time in English. So I hope to get like your comments, positive or negative. It really helps all the speakers improve. Thank you very much.